Hello guys, welcome back. In today's video I'm going to continue the part 6 video for building a diabetes. This is a predictor machine learning project, and in the last part video we left off in splitting our data into test and train data, and I show you how can you do that also. And what we want to do in this video is we want to create the algorithm, and then we want to fit the algorithm with the train data, and if we have time we can predict some data from that algorithm, and we'll see what's going to happen. So without further ado, let's get started. Alright guys, I'm back, and this is this is the last part video we left off, and I'm just going to delete this clear this plotting, because it will going to take so much time to scroll down, up and down. So now here we create our we split our data into train and test. Train and test. And now let's build our model. And now we are going to use CS super vector machine SVM. And before we do that, we have to also import the algorithm. So from if I'm not forgotten, let's try. Okay, from I think you know what, I will come back. I don't know where it is located, but I will come back after I check that. Okay guys, I'm back, and it is located in SVM, and then import SUV. I think let's see, SVC, but this is the same as saying super vector machine. I don't know why they call it SVS, but this is what we are going to use. We are going to use SVS, and now we imported our algorithm and we fit it to some variable here, and I'm going to run it, and now we successfully have algorithm to fit in. Now this is just easy to build our model. You know, in deep learning it is how it takes some step to do that, but in here all we have to do is just importing and giving some variable for that algorithm, and we can just fit it in that variable, and we can able to predict some data. But I know the loss will going to be very high because it's just simple algorithm here, and I'm going to also plot it and show you what it looks like when it's predicting. So now we have algorithm. Now let's fit it to into train data and test train. In X train and Y train, to be able to predict for the X's and some other values that doesn't seem before. Okay, let's say X train and Y train, and if I run this one, okay, I got error. Alright, okay, I got it. It's because I get some break, that's why. If I run this one from the top to the bottom, and we don't want this one, let's remove this. Okay, as you can see, we successfully fitted our data into the algorithm, as you can see here. Okay, let me explain what we did here. When we fit our data into this algorithm, the algorithm will going to be guess some value based on the data we put here. So if let's say we want to predict some data, and let's use the X test, and let's say the X the second index of data to predict into this algorithm we fit it. So it is easy to just also predict. We just also do I think I'm just going too fast because I explained this very detailed in the past project video, and if you are not understand it well, maybe watch some other video, or you can also watch mine, and I hope you will able to understand. Okay, we're just going to say predict and to x dot look, and we want to predict the second column. And if I run this one, okay, I got error. Okay, let me change this into numpy dot to numpy, and it will go to change it to numpy. Still I got error. Okay, I think maybe if we did like this fixed. Okay, yeah, it fixed. Alright, and let me explain what that I just did here. Okay, first to predict our data, we have to change this into some kind of number. It doesn't take the pandas data frame, because it have some, when we fit it, I think it is okay, but when predicting, or when we take a single data frame from the panda library, I think it does not going to predict. We will going to get some error, and for that reason I change it to numpy, and also I do this with bracket, because it will going to expect to predict more than, or you will going to expect to take a list instead of only some one dimension, and that's why. And it says 2 dimension because we have in the first dimension we have all data that we want to predict, and in the second dimension we have the features for the one data. I hope that makes sense. And for that reason we only want to predict one data, so we just say this will going to be the first dimension, and the second dimension will going to be in the columns of data. Okay, you know what, you might be confused, so let me show you. Let me print it out first. Okay, you see this is the data it looks like, and for every single column. when we change it to numpy. And if I did not change it to numpy, you see it just data frame, and the algorithm, this prediction meter is not expected to have data frame like this, and it just only want to take these numbers instead of these descriptions. So for that reason, I just change it to numpy. When you change it to numpy, it's automatically going to only take the numbers based on and the index will going to be based on the first will going to be in the first index, and so on for the other. And when I did that, it will going to change it like this. And if you put this one to in the prediction, it will not going to predict it, because they have to be two-dimension. Two-dimension means this will going to be one dimension, because it is one list. It's expected to have two lists. One is okay. If I did this one to like this one, or I can also just show you with 2 up to 5, let's say. You see, this is two-dimension. We have one bracket here and the last one here, so this is one dimension, and inside of that one dimension we have different value for each, and that's what's going to want to pass in here. And if we pass only one, we're going to be only one dimension. So for that reason, I added another bracket here, and I hope this explanation is kind of give you some intuition, or it's explaining you well. I know I did not pronounce it well, but okay, let's call this one to just hat or y hat. You can call it whatever you want, just to compare it. Or we can say y and or y h and y true, and then we can just say instead of x, let's say x train, we want to predict from the x train, and also from x, okay, let's say y, and I'll explain after. Is that okay? Yeah, I'm sorry, instead of y train, y test, and let's index the second one dot. This one will have to be iLook. We only want to index the index of iLook. Okay, okay, now let me explain what we did. We change is here, we want to take from the x test. What we did in the past was we just take it from this big data, so we want to pass some data that doesn't seen before. So that's the reason we just put test x train test, and also here we just say this will going to be predict for y to c. If we put the x feature, I will going to output y, right? So this is y hat or y h, I just say that. Okay, and the real value for this data will going to be this one, right? So we are going to compare it now. Okay, now let's compare it. Y hat and y t. Okay, let's run this one. Okay, you see, it is predicting the right one based on this SVC predictor project mode algorithm, and we just only sampling one data, but if we sample many data, we might get some loss, and but for this random choice we get the right one, and this is a good sign. And I hope these explanations explained it well, and will in the next part video I'm going to plot it what SVC is work in our data. So I will going to show you that in the next part video. I hope see you there. Goodbye.